Hello everyone. Today I will solve examples based on second property. We know that in Laplace transform we have some properties, and those properties are this one. First one is Laplace transform of e raised to at f of t is equal to f bar of s minus a, and Laplace transform of e raised to minus s at f of t is equal to f bar of s plus a. You already know how to find the Laplace transform of the given function when given function is of the form e raised to at f of t form. Today we will solve examples when the given function is of the form t raised to n into f of t. We know that Laplace transform of t raised to n into f of t is minus 1 raised to n d raised to n divided by ds raised to n into f bar of s. Here if n value is 1, we have to differentiate that Laplace transform. We have to differentiate the Laplace transform one time. If it is t square into f of t, then differentiate twice the Laplace transform of this f of t. Like that we have to solve. We have some examples here. Find Laplace transform for the following function. First is t cos at, t cube cos ht, and third one is t e raised to minus 2t sin 4t. Here first one is t cos at. In that f of t is cos at. See here example means function is given in the form t raised to n into f of t. Here f of t is cos at, t raised to n. Here n value is 1. First we have to find Laplace transform of f of t. We know that Laplace transform of f of t is equal to f bar of s. So we have to find first Laplace transform of this given f of t. Laplace transform of cos at is equal to, we know that Laplace transform of cos at is s divided by s square plus a square. Next is Laplace transform of t into f of t. F of t is cos at, which is equal to, here it is t raised value of t is 1. We know that when n is equal to 1, formula is, here I will write the formula. When n is equal to 1, we have Laplace transform of t into f of t is equal to minus d by ds of f bar of s. We know that f bar of s is Laplace transform of f of t. Laplace transform of f of t is s by s square plus a square. Here it is t into f of, Laplace transform of t into f of t means we have to differentiate this f bar of s once with respect to s. Now we have to differentiate. First I will write minus d by ds of s divided by s square plus a square. We have to differentiate this term with respect to s, which is equal to, we have to apply u by v rule. So this is minus, keep as it is, v as it is, v square plus s square plus a square into differentiation of s with respect to s is 1 minus, now keep u as it is, differentiation of this one, we get a is constant, this is 2s, differentiation of s square is 2s divided by s square plus a square whole square, because differentiation of u by v is v as it is, differentiation of u minus v, u as it is, differentiation of, v as it is, differentiation of u, then u as it is, differentiation of v divided by v square. Now which is equal to, apply this minus, we get minus s square minus a square, minus into minus, plus 2s square divided by s square plus a square whole square which is equal to here s square, here 2s square. We get, sorry, it is minus s square, not s square, minus s square plus 2s square is s square minus a square divided by s square plus a square is the answer. Therefore, Laplace transform of t into cos at is s square minus a square divided by s square plus a square whole square. This is the answer. Similarly, second one is t cube cos h t. For this one, just observe this example. This is cos h t. We know that cos h t can be written as e raised to t plus e raised to minus t divided by 2. When we write here cos e raised to t plus e raised to minus t divided by 2, take 1 by 2 constant here, take outside, we get t cube into e raised to t plus t cube into e raised to minus t. Recall the first property, means after that we will get the function which is of the form e raised to at into f of t, means like this. We here I am applying cos ht is e raised to t plus e raised to minus t divided by 2 in place of cos ht. 1 by 2 take common, we get e raised to t into t cube plus e raised to minus t into t cube. See here, these two function of the form e raised to at into f of t, e raised to at into f of t form. That means here we have to apply the first property, means when the given function is of the form e raised to at into f of t, then Laplace transform of e raised to at into f of t is f bar of s minus a when it is e raised to at, and f bar of s plus a when it is e raised to minus at. Similarly, here we get Laplace transform of f of t is equal to 1 by 2 into t cube. Laplace transform of t cube, f bar of s is Laplace transform of this f of t. Laplace means L of t cube, Laplace transform of t cube where s changes to s minus 1, and Laplace transform of t cube where s changes to s plus 1. We know that Laplace transform of t cube is 3 factorial divided by s raised to 4, means here it is n factorial divided by s raised to n plus 1, which is equal to, we know that Laplace transform of t raised to n is n factorial divided by s raised to n plus 1, when n varies from 1, 2, 3 so on. Here I am using this formula. So it is 3 factorial divided by s raised to 4. 3 factorial is 6, which is divided by s raised to 4. Now t cube cos ht is 3 factorial is 6 divided by, here it is, first one is s changes to s minus 1. Therefore it is s minus 1 raised to 4 plus this plus as it is. Then next one 6 divided by s changes to s plus 1. Therefore it is s plus 1 raised to 4. Therefore Laplace transform of t cube cos ht is half into 6 divided by s minus 1 raised to 4 plus 6 divided by s plus 1 raised to 4. See, this problem belongs to first property. Here I am using first property to solve this one. This is very easy as compared to the second property. See this note here. Here we should not prefer to work the problem similarly to the previous problem, as we have cos ht which can be converted to the form e raised to at plus e raised to minus at divided by 2, so that it will be highly convenient to apply the shifting property. Shifting property means first two property are very useful to solve this example. Just go through the examples clearly. You can easily understand what are the difference between these two properties here. Next one is, next given function is t e raised to minus 2t sin 4t. See here we have three terms here. When we take these two terms, means e raised to minus 2t sin 4t, we have shifting property here, means first property we have to apply, means this is of the form e raised to at into f of t form, but when we apply all the three terms we get t into f of t form. Here take f of t is equal to minus 2t into sine 4t. Observe this function is of the form e raised to at into f of t form, means it is shifting property we have to apply here. First we have to find what is the Laplace transform of this sine 4t, because when it is e raised to at f of t forms, we have to first find what is the Laplace transform of this f of t, means Laplace transform of sine 4t is 4 divided by s square plus 16. We know that Laplace transform of e raised to minus at f of t means like this form, which is equal to f bar of s plus a. Here means f bar of s is 4 divided by s square plus 16. We have to change here s plus a. Your a value is 4 here. So Laplace transform of f of t, which is equal to Laplace transform of e raised to minus 2t sine 4t. Then Laplace transform of sine 4t. When we apply this property, we get Laplace transform of sine 4t where s changes to s plus 2. Laplace transform of sine 4t is 4 divided by s square plus 16. S changes to s plus 2. Here we have to change, which is equal to 4 divided by, just change s by s plus 2. We get s plus 2 whole square plus 16, which is equal to 4 divided by s square plus 4 plus 4s plus 16, which is equal to 4 divided by s square plus 4s plus 20. 4 plus 16 is 20 here. Therefore, it is Laplace transform of e raised to minus 2t sine 4t. First part is over. In this example, we have to apply first both shifting property and the second property, which is also called derivative of the transform property. This is first property, here is over. Next we have to find the Laplace transform of this given function t e raised to minus 2t sine 4t. Next is Laplace transform of t e raised to minus 2t sine 4t. Here n value is 1. So we have to differentiate this Laplace transform once with respect to s. Therefore it is minus d by ds of Laplace transform of e raised to minus 2t into sine 4t. Here it is. So minus as it is, differentiate this one, keep v as it is, differentiation of 4 is 0, minus 4 as it is, differentiation of this one is 2s plus 4s divided by this whole square, s square plus 4s plus 20 whole square. Therefore we get minus of here 0 into something is 0, minus 4 2s plus 4 divided by s square plus 4s plus 20 whole square. Here it is minus plus, we get, and also take 2 common here, it will be 8s plus 2 divided by s square plus 4s plus 20 whole square, which is Laplace transform of t e raised to minus 2t sine 4t. Like this we have to solve the examples using the second property. In these examples we are using for both first and second property, because first here terms are t e raised to minus 2t sine 4t. Here it is, when we apply this is when we consider this as f of t, here we get function is of the form e raised to at f of t form. So first we have to apply the first property, that is shifting property. Next we have to apply the second property here. In the same way, solve these two examples. Here it is t square sine 80. Here when n value is 2, so you have to differentiate Laplace transform of sine 80 twice. Next is t raised to 5 for e raised to 4t cos h 3t. Here we have to apply for these two terms. You have to apply first property, after that second property. Next, fourth example, find LT of t cube sin t. Given here f of t is sin t, then L of f of t is equal to Laplace transform of sin t is 1 divided by s square plus 1, because here a value is 1, therefore we have 1 divided by s square plus 1. Then Laplace transform of t cube sin t. See here, the given function is of the form t cube t cube into f of t. Here n value is 3, therefore we have minus 1 raised to 3 d cube divided by ds cube. F bar of s is 1 divided by s square plus 1. We have to differentiate this term thrice. Minus 1 cube is minus, write d cube by ds like this, d by ds into d by ds of this term. We have u by v form here, s square plus 1 as it is, differentiation of 1 is 0, minus differentiation of keep 1 as it is, differentiation of this is 2s divided by s square plus 1 whole square. Now it is minus 2s divided by s square plus 1. Therefore d by minus will be plus. We get d by ds of d by ds into d by ds of 2s divided by s square plus 1. D by ds as it is, differentiate this one, we get s square plus 1 as it is, differentiation of 2s is 2, minus 2s as it is, differentiation of s square plus 1 whole square is 2 as x raised to n is n into x raised to n minus 1 n minus 1. Therefore 2 as it is, differentiation of 2 as it is s square plus 1, and s square differentiation is 2s divided by s square plus 1 raised to 4. Then it is d by ds of, here it is 2, in these two terms 2 and s square plus 1 common, take outside, we get 2 into s square plus 1, remaining is s square plus 1 minus, here s square and 2 is take common, remaining is 2 into 2 4, s into s square. Therefore it is s square plus 1 minus 4s square divided by s square plus 1 raised to 4. Here s square plus 1 and here it is raised to 4, one term will be cancelled. We get Laplace transform of t cube sin t is 2, here 2 constant, take outside the differentiation, 2 into d by ds of 1 minus 3s square divided by s square plus 1 whole cube. Now we have to differentiate this one, 2 constant keep as it is, this is v, s square plus 1 whole cube as it is, differentiation of 1 minus 3s square is minus 3 into 2s square, therefore it is minus 6s minus 1 minus 3s square as it is, differentiation of this is 3 into s square plus 1 whole square, and differentiation of s square is 2s divided by s square plus 1 whole raised to 6. Now it is 2 minus 6s minus 6 into s square plus 1 whole cube minus, here it is 3, here it is 2s, therefore it is minus s minus 6 into s minus 1 minus 3s square into s square plus 1 whole square divided by s square plus 1 whole raised to 6. See here minus 6s common, take outside, here I am taking minus 6s, therefore it will be plus, remaining is s square plus 1 whole cube plus 1 minus 3s square into s square plus 1 whole square divided by s square plus 1 raised to 6. Next is it will be minus 12s. In these two terms s square plus 1 whole square is common, take outside, remaining here it is s square plus 1 plus, here it will be 1 minus 3s square. Denominator term is as it is. Now we have square and here two terms get cancelled, s square minus 3s square is minus 2s square, it will be 2 minus 2s square divided by s square plus 1 whole raised to 4. Next is in these two terms take minus 2 common, we get it will be minus and this is plus. So I will write s square minus 1 minus 2 into s square minus 1 divided by denominator term is as it is minus 2 into minus 2, it will be minus into minus plus 12 into 2 is 24s s square minus 1 divided by s square plus 1 whole raised to 4. Therefore, Laplace transform of t cube sin t is equal to 24 into s square minus 1 divided by s square plus 1 whole raised to 4. Like this you have to find the Laplace transform when the given function is of the form t raised to n into f of